Okay, well, guys, welcome back to the continuation of the lecture, chapter 11. So far in the first video, we have just stopped to at the case where we tried to explain how you can compare population means in the case where you assume that the variances of the two uh, populations or the two samples are equal. Okay, so they are independent and equal. So what about the case where we assume that the standard deviations or the variances of the two independent population, they are unequal? Okay, this is the case that we are trying to stress here. And in case where the two populations are said to be independent, but the variances, okay, or the standard deviation, okay, of the populations are unequal. In this case, we will use this specific test, t-test. So here we are saying that if it is not reasonable to assume the population standard deviation are equal, so it is not reasonable, which means that we assume that the population standard deviation are unequal, or we can also say that the population variances, okay, are unequal. Then we compute the test statistic shown to this right. So, and that is how we will determine the test statistics, which will be, we will take the sample mean of the first sample, okay, the mean of the first sample minus the mean of the second sample divided by the square root of the variance of the first sample divided by n1, which is a sample size 1, plus the variance of the second sample divided by n2. That is how we will determine the t statistic. So, however, remember here the variances or the standard deviation are unknown. In the first case where they were known, so here we were using sigma square 1, okay? In the case where the variances were known. Now, in the case where we don't know the variances or the standard deviation of the population, so we will just replace sigma 1 square by the the variances of the sample 1, okay, as we always do since we've started. If the standard deviation of the population is not known, we replace it by the standard deviation of the sample. So, but now one more case will arise in this case is how do we determine the degree of freedom that will allow us to compute the critical value, okay, the t critical value. So now the degree of freedom will be computed using this very complicated formula, but very easy to use. It appears very complicated in eyes. So to get the degree of freedom, remember in the first case, the degree of freedom were obtained by taking 1 minus 1. Okay? That's how we're trying to get the degree of freedom. And we will take the level of significance and we will go in the table of student and we get the t critical value. But in this case, the degree of freedom will be determined using this formula. In the case where we don't know, or in the case where the variances of the two populations are unequal. So now the degree of freedom will be obtained by taking the ratio between the sample 1 variance and n1 plus the sample 2 variance divided by n2, okay, and we square everything divided by the same ratio in the sample 1 divided by n minus 1 plus the same ratio given by the variance of the sample 2 divided by n2 square divided by n2 minus 1. So by doing this machination, this calculation here, we will get the degree of freedom. Okay, we will know how many degree of freedom we will have in order to be able to calculate the t critical value. And then now we will compare the t statistics with the t critical value in order to decide whether we will reject the null hypothesis or not. Let us take an example so that we can understand it better. Okay, so here we are, which is a very good and understandable example. So personnel in a consumer testing laboratory are evaluating the absorbency of paper towel. They wish to compare a set of store brand towel to a similar group of name brand towel. So here you have store brand towel and name brand towel. So for each brand, they dip apply of the paper into a tube of fluid, which allows the paper to drain back into the vat for 2 minutes, and then evaluate the amount of liquid the paper has taken up from the vat. A random of 9 brand paper, so store brand paper in the first category, absorbed the following amount of liquid in milliliter. So they just draw 9 sample, so, and this is the amount of liquid for sample 1, 2 for the observation 2, for the first time they 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 did the experiment, and they get this number of amount. So for sample 1, they get this number of amount of liquid in milliliter. So now, an independent random sample, do you see? So we are saying a second random sample, but is independent. So I'm emphasizing at this level, we are still evaluating the case where you have 2 independent samples, which are drawn from 2 independent populations, okay? 2 independent populations. But here, in this case, we are not assuming that these 2 samples, that their mean, okay, have equal variances or equal standard deviation. No, we are assuming that the variances, okay, the variances of these 2 mean they are unequal. So in this case, because the sample is still independent, so we will use the same framework. But remember, to get the statistics, we will compute the statistics using what I've explained just before, above here. So now this is the second sample, which has a couple of 12 observations. Now they are telling us to assess whether these 2 samples, the mean of these 2 samples, okay, they are equal or different. Okay, so that is how we will do. In the first step, we will state our null hypothesis. Okay, our null hypothesis, we say H0 is the mean in the first sample is equal to the mean in the second sample, and the alternative is that the 2 mean they are different. The level of significance is 10%, is given in the problem. And to find the appropriate test statistic, okay, we need first to assess whether these two samples, they have an equal or unequal variances. So if we find that they have unequal variances, here the formula we will use. But if we find that they have equal variances, instead of using this sample variance, we will use this population variances, and given that this population variances is given in the problem. Okay, now how do we know that we will use this T formula of unequal variances? So guys, I'm giving you the procedure. Since we know the data, and these are the data, so I have presented the data here. So let me just remove this. And here we have these two brands. We have the store and the name. So now, to be able to determine whether these 2 samples, okay, they have equal or unequal variance, so you need to test them. And we test that using an F distribution. Okay, if you want to test for equal variances or unequal variances, we use the F distribution, the Fisher distribution. And we will talk more about this when we will study we will do the ANOVA chapter, which is the analysis of the variances, where we will see that we will no longer use the Z or the T distribution, rather we will use the F distribution. So to get that, guys, you go to data and you take data analysis, you click on it, and you will go up and you will see F test two sample for variance. F test two sample for variance. So we want to test whether these two samples have equal or unequal variances. So if we found the evidence that these two samples have equal variances, then we cannot use the formula I have just explained. But if we found that their variances are unequal, therefore we will apply this formula, the formula I have just explained here. Okay, we will apply this formula and we will get the critical value using this degree of freedom. So now you go to F test two sample for variance and you say okay, and a window will pop up like this. So once it popped up, it will blank without any information. Okay, it will blank like this, and you come here to input range variable 1. You just click there and you copy the numbers. So if you want also to copy the label here store, you will now be obliged to tick here labels. But since I'm not copying the label, so I will not tick label. Okay, and you come to the second range, you copy the observations of the sample 2. Okay, so since I did not copy the labels, I will not tick. Okay, and I will come now here, and this test is using 10%. Remember, the level of significance was given in the problem and is 10%. Okay, so in this problem we are testing, everything we are testing is at 10% level of significance. It's given here. Use 10% significance level. So now I have put my level of significance, and then I will come here and I tick here output range, and I will tell the software Excel that okay, I want my output to be placed here at this range. And after that I will click on OK. You click on OK. Here you are. So actually these are the results for testing, the result to test for equal or unequal variances. And here are the means. So the mean for the sample 1, and this is the mean for sample 2, and this is the variance for sample 1, and this is the variance for sample 2. Easy. The number of observations they are given and the degree of freedom they are given. And this degree of freedom is just the number of observation minus 1. Okay? So now, here's the F statistic, which is calculated. And here is a one-tail critical value, which is 0.0115. So how you decide whether these variances are equal? So the null hypothesis here, you are saying that the two variances they are equal, 11.02 and 2.62. You are saying that they are equal. That is your null hypothesis. Look at your p-value. The p-value of the test is 0.015, which is less than 0.05. This p-value is less than 0.05. Because the p-value is less than 0.05, which is the one tail test. But if you want to consider it, okay, in the case of the two tail test, okay, you will multiply this p-value by 2. So it will still be less than 0.05. Because it is less than 0.05, so we reject the null hypothesis of equal variance. In other words, we are saying that this variance, the two variances of these two samples, they are not equal. So now, guys, that is how you can arrive to tests and to found the true the true test you will apply in this case. Okay, so because this null hypothesis have been rejected, the null hypothesis of equal variance have been rejected, and now we have evidence that these two samples has unequal variance, and therefore the true test to be applied will be the one that uses this formula and this degree of freedom. Simple. Then now we go to calculate the statistics first. So that is why we say here we will use an equal variance t-test. Okay, and I will show you in Excel how you can compute it in Excel. Remember, I've showed you how you can compute the equal variance t-test. Now I will show you how you can compute the unequal variance t-test in Excel. So now we are here, and we can now state, we know the null hypothesis that in the alternative, for instance, we don't have a sign of direction, and we know the decision rule. We know, because we don't have an inequality sign in the alternative hypothesis, we know that if we use, we know that we have a two-tailed test, and then to reject the null hypothesis, we use this decision rule. So the calculated t must be more than t alpha minus 2 and minus 1 degree of freedom. But remember now, here is a degree of freedom. In our case, will no longer be n minus 1, but will rather be computed using this formula. That is the difference, using this formula. Okay, quickly finish. So that is how we do. Now here we are. So we state the decision rule. The decision rule will be t more than t alpha divided by 2 degree of freedom, and I've showed how you determine the degree of freedom, or t minus, because it's a two-tailed test, minus t alpha divided by 2 degree of freedom. So the first things here, in order to get the decision whether we can reject or not the null hypothesis, we need first to calculate the t. So, and we can calculate the t, okay, by taking the sample mean 1 minus the sample mean 2 and the square root of the standard deviation, like the variance of sample 1 divided by n and the variance of sample 2 divided by n2. Okay, but here guys, one thing that I want to show to you is here we are. So now before we do this, we apply this formula, we first need to find the mean, and we have this distribution, so we know how we can calculate the mean if we have this distribution, okay, and this distribution. So now here I have did some descriptive statistic, and we found that in sample 1, which is a store, we have 9 observation, n is 9. For name, we have 12 observation, and the mean is 6.44 for sample 1, and for sample 2, the mean is 9.417. And the standard deviation is 3.32 in the sample 1, and in the sample 2 is 1.621. So these are the statistics we need, and especially the mean and the standard deviation. So if we replace this formula, so we can take the mean in sample 1 is 6.44 minus the mean in the sample 2 is 9.417. Okay, we divided by square root of the standard deviation over power 2 of sample 1, which is 3.32 over power 2 divided by n1, which is 9, plus the standard deviation of sample 2 over power 2, which is 1.621 over power 2 divided by n2, which is 12, and we get it as a statistic of minus 2478. Simple. Now, since we know the calculated statistic, we need now to compute the critical value, the t critical value, from the table of the student distribution. But in order to do that, we know already the level of significance, which is alpha is equal to 10. But because our test here is a two-tailed test, so now we'll take alpha divided by 2. It will give us the one side level of significance of 0.05. That is why now we wrote here that we can reject the null hypothesis if t is more than t 0.05, which is a one side. And now, comma, degree of freedom is 10. So how did we found this degree of freedom? So we use this complicated formula I've explained to you in order to get the degree of freedom. So we take the standard, the sample standard deviation over power 2 divided by n1. That's what we have here. Plus for the sample 2, you divided by the sum, okay, standard sample standard deviation over power 2 divided by n1 square, you divided by n minus 1. So you replace everything in this formula, you will get a 10.88 degree of freedom. So we can just take 10 degree of freedom. Okay, we consider in this case 10 degree of freedom. So don't around, you just take 10 degree of freedom. So now we will have t 0.05 level of significance because it is a one side, and 10 degree of freedom, or minus t 0.05 and 10 degree of freedom. So after that, you can now go in the table of student, okay, and you look at the value at 10 degree of freedom, okay, what is the critical value, and the level of significance is 0.05, is a one tail. So that is what we will do. We can quickly go in the table of student, the student distribution. Sorry for this, it is coming. Here we are. So now we scroll down. In our book, we have that table. Remember, we've been using it. Okay, so I can activate it because this one. Sorry, I'm very sorry. I will do it quickly. Yeah, here. Let me open. Here we are. So we need to go and find that value in the table of student. Okay. In the table of student, we just scroll down there. Okay. Here we are. So we'll just increase the font so that everybody can see. Here we are. So this is a table. So we have 10 degree of freedom, and we have the level of significance. Okay. The level of significance for one-tailed alpha is here, 0.05. Okay. Okay. Let me check. So yeah, okay. We are trying to find the critical value. So we have degree of freedom. We have 10 degree of freedom. Okay. And here we are. Okay. So we have 2 point, let me check. We have 2 point, sorry. Yeah, here we are. We have 10 degree of freedom. I'm very sorry for this. We have 10 degree of freedom, and we look at in the table level of significance for for one tail, level of significance for one tail test alpha. Yeah, here. So we have 0.05. We are here, which correspond for the two tail, it will be 10%, which correspond to the 90% of confidence interval. So now it will be here. This is a value, is 1.812. Here we are. This is the value you will take. Okay, and you will place that value somewhere here, here. Okay, somewhere here. That is a value of 1.812. Okay, and minus 1.812. And then I will compare the calculated test statistic with the critical value. okay, if this statistics is more, okay, than 1.8212, 1.812, we reject the null hypothesis. And as you can see, this value is more than 1. If you take it in absolute, so it will be positive. 2.478 is more than 1.812, and therefore we reject the null hypothesis. But in the left tail, this value is less. You see, we reject if this statistics is less than 1.182, because they are all negative. You can see minus 2.47 is less than minus 1.82, and this is the conclusion here we are giving here, that we have rejected the null hypothesis. Okay, so quickly, because I want to finish, but I want to show you also how you can do it in Excel. Here we are. So since we've concluded that we need to, the two samples have unequal variances, so we need to use a t-test, okay, for unequal variances. So now we'll go to data analysis quickly, and we will come here. So in the first case, we have showed in the case where we use the t-test when the two samples are assumed to have equal variances. We have showed this case. But now here, pay attention, guys, and take note to this. So before, if you are given a sample like this, and they are telling, they say that the two samples are independent. So you must put in mind that there is two cases that you can find. The first case is that the two samples may have equal variances, or the two samples may have unequal variances. So if they have equal variances, you use this test. And if they have unequal variance, you use this test, which are very different. Now, how will you know that these two samples, they have equal or unequal variances? You run the F test. The F test. And if you find that the probability value is less than 0.05, okay, after running, and in this case here, we have run the F test, and we found that the probability value are less than 0.05, the one-tail probability value. It simply means that we reject the null hypothesis of equal variance, and therefore we will run the t-test for unequal variance. But if this probability value is more than 0.05, it can be 0.123, 0.5, it can be 0.23. You see, it's just more than 0.05. It simply means that we fail to reject the null hypothesis of equal variance, and therefore we will run these tests where we assume equal variances. So that is how you do it technically, guys. So now in this case, we have the case of unequal variance, and we will click OK. So here, when it opened, everything will be empty. You don't have anything. Okay, and we will have to fill the information in the package, the Excel package. So the first range will be, we are taking the first sample. In the second range, we take the observation in the second sample. So because I did not select the label, so I will not tick here. So we are testing at 0.1 at 10% as it is given in the problem. And now we'll say, okay, where do we want to put the result? And I'll tell the software that I will just want to put the result here in this range, okay? And everything is set up as I want, and I will run okay. Here we are. You see, we have the same information, that the mean, they are the following. We have the variances are given, the number of observation, the hypothesis. Here now we are saying that the sample mean, okay, the sample mean here, the sample mean of the store, okay, here in the first sample, and the sample mean in the second sample, which is in name, brand. So there is no difference, they are equal. That's the hypothesis. Okay, here's the degree of freedom, and this degree of freedom is obtained from that formula. And remember, for us theoretically, we maintained 10. Okay, we maintain 10, but the software is rounding to 11. Okay, to 11, but for us we maintain 10. Okay, so now we have 11, And now here's a statistics which is minus 2.473, which is the same statistics as we have obtained it. And here you will have the critical value, okay, the T critical value, one tail, okay, and the two tail, which is 1.795. So it's because here it used 11 degree of freedom. Reason why we have these small differences of the critical value. But if you use 10, you will get the exact critical value we have found in the here. You see, that's what I'm saying, because the software is using this critical value of 11. The 11 number of degree of freedom is 1.796. Okay, the software use 11 degree of freedom. This is a critical value in the student table, and that is what is reported here. Okay, but still we have the same conclusion that we reject the null hypothesis. So that is how also you can use Excel in order to compute the two sample mean, assuming unequal variance. You compare the two sample mean when you assume unequal variance. So quickly guys, to go and finish the lecture. Now we have this last case when now we are interested to test two samples mean, okay, but those two samples are dependent, are paired sample. So remember what we've been explaining so far, it was the scenario where we assume that the two samples come from two independent populations, and therefore the samples also are independent. But now what if the two samples are dependent because they are drawn from two dependent populations? So here we are saying that the dependent sample are samples that are paired. They can be called, if you say paired sample, it means that dependent sample or related sample in some fashions. So let us look at these two examples. If you wish, for instance, to buy a car, you look at the same car at two or more times at different dealerships and compare the prices. So if you wish, for instance, another example, to measure the effectiveness of a new diet, you will weight the dieter at the start and at the finish of the program. So you see how here that this kind of example, they show some sort of dependency. So now if you have two samples that are dependent and you want to test whether their means are equal or not, so we use the following formula. So we'll use a T formula, okay, and the T formula will be equal to the differences, the mean differences between the two paired sample, the two dependent sample, okay, divided by the standard deviation of the difference, okay, divided by square root of n, which is the number of pair, which is the number of observations. Let us take a quick example. So here you have nickel saving and loan, which is to compare the two companies. It used to appraise the value of residential homes. Nickel Savings selected a sample of 10 residential properties. So this is the home. You have 1 to 10 property. And Shedal both farm for approval. So you have two farms. And each farms have its own prices. Okay, for home 1, this is the price for this Shadek company. And for the same home, this is the price for Boya company. So now the results, so he shall both farm for appraisal. So the results reported in US dollar are shown in the table as I have explained it. So at the 0.05 significance level, can we conclude that there is a difference in the mean appraised value of the home? So at this level of significance, which is 0.05, can we conclude that there is differences in this mean for these two companies? Okay, so that is the question. So now to do that, here you see that these two samples, they are dependent. Okay, and there, in this case, we will use this T formula. Let's go quickly to finish. So now the step is the same. The first step is that you set the null hypothesis. The null hypothesis, you are saying that the mean difference between the two samples is 0. So mu d means that the difference in the mean of the two samples is 0. And the alternate hypothesis is saying that the mean difference in the two samples, they are different. So actually the two difference have different mean. The two samples have different means. So now we set the null hypothesis, the significance level, which is 0.05, and remember significance level is the probability of rejecting the null hypothesis when it is true. So now we found the appropriate test statistic, and here we use a t-test because the two samples are paired. Now here, guys, remember here, because in the alternative we don't have a direction sign, so we use the t formula. We use the t formula, but in which scenario? In the scenario of we are in this case here of a two-tailed test. The reason why here I've just did this summary. So we'll reject the null hypothesis if the calculated t statistics is more than t alpha minus 2 n minus 1 degree of freedom. So in this case, we apply the same degree of freedom formula we have been using so far. And if t will be also less than minus t alpha minus divided by 2 and n minus 1 degree of freedom, we will also compare, and then we can find the decision. So now, how do we do the differences? That is what I'm speaking about here. So now to get the differences, so I just repeated this table. So here you have the Shadek company with the mean for homes, home 1, this is the mean, and you have Voya, this is the mean for the same home in price. Okay, so now to compute the difference of this mean, that's why we are saying the mean difference. You just take this the mean for Shadek minus the mean for Boya. So if you take 235 minus 228, you will have 7. And 210 minus 205, you have 5, and so on. So you compute the differences in the mean of these two samples. You have the numbers, and you sum them. Once you sum them, you can be able now to determine, okay, the mean difference of the sample. The mean difference of the sample, and which we have labeled by d bar. The mean differences of the two samples will have the summation of the differences, okay, of the mean of the two samples, which will be the summation is of d, and we have d here is 46, so it will be 46 divided by n. N is 10, the number of homes, okay, and we'll have a mean of 4.60. This is the mean. And after you have calculated the mean, now we will be interested to, because remember in the formula here, we have the standard deviation of the differences. Okay, so we like to have also this to calculate the standard deviation of the differences. And remember, to get the standard deviation is just the square root of the variance. So we can go through the variance and get the standard deviation. Okay. Now we can now take, to get the variance, we always take d. So now we have a new distribution here of the difference. So now we'll take the d, the difference, minus the mean of the difference. Okay, so if you take 7 minus 4.6, you have 2.4. 5 minus 4.6, you have 0.4, and so on. Okay, and if you sum everything, you will get 0. So it gives a summation of 0. Okay, now we can also take the square of these differences, of the difference minus the mean, and square. So if you take 2.4 and you square, it will give you 5.76. 0.4 you square, it will give you 0.16, and so on. And also you will sum everything, it will give you 17440. Okay, and after that, now we can determine the standard deviation. Remember, the standard deviation is the square root of the variance. or to get the variance, we will use this, okay, which is the summation of this. So if you take the summation of this, okay, and you divide it by n minus 1, so you have the variance. And to get the standard deviation, now you'll get the square root. So that is what we have repeated here. So if you take summation of d minus d bar square divided by n minus 1, this is the variance. And once you take the square root of everything, you get the standard deviation. So that's what we have calculated. We know that already this part here is 147.40 minus n minus 1. N is 10, number of variance is 10 minus 1. Okay, and with square root, we have the standard deviation of 4.40. Since we have now the standard deviation, so we can be able to get the t statistic using this formula, which will be the mean difference of the samples difference, okay, divided by the standard deviation divided by square root of n. We will have now 4.6, okay, this 4.6 here we have shown is this d divided by the standard deviation is 4.402 divided by square root of n, 10, and we will have a t statistics of 3.305. So now we can also be interested we can also go now and try to find the critical value, and we have said that the critical value will be obtained by taking t alpha divided by 2 n minus 1 degree of freedom. And remember here the level of significance is known as 0.05. So if you divided it by 2, it will be 0.025. That's what you have here, t of 0.25, and the degree of freedom will be n minus 1. So n is 10, minus 1 is 9. So we have just repeated a part of the student distribution here. So we have 9 degree of freedom, okay, and we have a two-tailed test, and it is giving us 5 divided by 2, which is 0.025 level of significance. And once we go now, level of significance for one-tailed, okay, we are here 0.025. And if you do the junction with 9 degree of freedom, you have a value of 2.262. What is the rule? Reject if the t statistics is more than the critical value. The t statistics obtained is 3.305. You can see it, which is more than this value, critical value of 2.262, and therefore we can reject the null hypothesis, which states that the mean differences between the two samples is equal to 0. So actually the mean, they are not equal to 0. So that's what we have just say, that the computed value of t is greater than the higher critical value. So our decision is to reject the null hypothesis. We conclude that there is a difference in the mean appraised value of the home. So guys, let us now see how you can also do it in Excel. In Excel, it is very simple. So here's the exercise we have, okay, of the two homes. You can see the home A, B, C, which is 1, 2, 3, 4. Okay, the same things. And here you have the Shadek and the Boyer homes. So now to get that test, the t-test, you go to data and you click on data analysis. And here now you come, you see, we are not in the case of t-test for two samples assuming an equal variance. No, we are not in this case, because this case is where is applied in the case where we have two independent samples. In our case, the two samples, they are dependent. So we are not in the case where we assume an equal variance, because also this test assume that the two samples are independent because they come from independent populations. We are not also in the case of the Z test, okay, here, and we have explained when can you use a Z test for two samples for me. So now we are in this case here, t-test for paired two samples for mean. This is a test we will use in this case because our samples are dependent. So, and you click there, you say okay. So now you will fill in the informations as we always do. So I will untick the labels. So I will come here and I will select sample 1, and I will come here, I will select sample 2. Okay, I untick label. So the hypothesis mean is that the mean difference is 0. That's why I keep 0 here, 0. So I'm not doing label because I did not select the labels. But if you want to select the label, you will select everything. The label you will also tick. You can tick them. So okay, the output I want them to be stored. So I remove this. I want my output to be stored in this range. Okay, you just select there and I can say okay. So once I click OK, here's the result. As you can see, so here they are giving you the sample mean, okay, the mean for each sample first, and the variances, their variances, the number of observations. So you have 10 observations in each sample and you can see them. So now you have the Pearson correlation. This is not interesting at this level. So this is the hypothesized mean. We are saying the mean difference is the mu d is equal to 0. Degree of freedom is n minus 1. We will have 9. Here's the t statistics, which is the same with what we have calculated here. Okay, manually of 3.305. That will have 3.045. If you are around, it will reach to 3.305. And then you have the critical value of 1.833. Okay, the one side critical value. But remember here we are using the two-side critical value because it is a two-tail test. Okay, the critical value will be 2.262. Okay, this is the critical value. Remember here we have calculated it is 2.262 because it is a two-tail test. That is a critical value, and there you can decide because this is more than the critical value of the critical two-tail test. Okay, we now reject the null hypothesis and conclude that the mean difference is not equal to 0. So guys, that is how also you can do the paired two sample for mean, okay, in Excel. It's very simple. So if you are asked to test in Excel, you are given data, which for sure you can be given data. So you need first, in order to decide whether, and especially in the case where the sample are said to be independent, you see that the sample are not dependent. So you can first, and remember, if it is a small sample, so the observation are less than 10, it simply means that you use t-distribution. But which t-test are you using? Are you using the t-tests that assume equal variance or unequal variance? To decide, you run the f-test, and the f-test will indicate whether the variance are equal or not, and then you can be able to use to choose the true t-test to apply in the case where your sample are independent. But if your sample are dependent, so you don't need to run the f-test. Okay, because they are dependent, you will just go forward and you take this test, the paired two sample test. Okay, but in the case where your sample or your population are said to be independent and you have big sample size that are more than 30 observation and the standard deviation of the population are known, you use a z test in order to decide whether you reject the null hypothesis or no. So thank you very much guys for watching, and I will now come with another video to do some practicals and we will end up this chapter here.